The Microprocessor Development Program is a project, initiated and funded by Ministry of Electronics and Information Technology, Government of India. The objective of the project is to design and develop a family of microprocessors, using open-source instruction set architecture, and develop indigenous capability to take up complex designs in microprocessors, and related areas. The project is executed in 2 phases, with a total duration of 4 years and C-DAC as the main implementing agency. C-DAC has successfully completed Phase 1 of the project with the design and implementation of 64-bit quad-core processor with RISC-V ISA, out-of-order execution, MMU, multi-level cache, interrupt controller, FPU, and AXI4 interface. The quad-core processor has been ported on FPGA, and the performance demonstrated with standard benchmarks. This is the architecture of the quad-core SoC. The quad-core processor comprises of 4 cores, each supporting RISC-V IMAFD instruction set. FPU, MMU, 32 KB L1 instruction cache, and 32 KB L1 data cache, connected through a cache-coherent interconnect and has 1 MB of banked L2 cache. The quad-core processor is interfaced with various peripherals, such as interrupt controller, DDR4 memory controller, BRAM controller, 1 gig Ethernet MAC, and UART through AXI4 bus interconnect. The quad-core SoC has been implemented on a Veloce prototyping system having 3 Vertex Ultrascale VU440 FPGAs, with a capacity of 25 million ASIC gates each, which are interconnected through high-speed FRCs. The quad-core design comprises of about 30 million gates, and uses 2 FPGAs in the system. The FPGA board is connected to a host PC through 1 gig Ethernet port, and UART. The 1 gig Ethernet is used for downloading the Linux image, and transferring data to the booted system. The UART is used for displaying bootloader messages, and Linux terminal from the board, to the host PC running Minicom. After power on, a simple bootloader is executed, to transfer the Linux image to the DRAM. Here, we can see the Linux image is being transferred to the FPGA board. After the transfer is completed, the quad-core system is now booting Linux. Now, we see the Linux prompt on the screen. Here, we can type any Linux command. Now, we can run a demo application on the quad-core system, which identifies objects in the given images. The application is run and is now waiting for input image. To transfer the input image and display the result image, an application is run on the host PC. The image is transferred to the system and being processed. This open-source YOLO-based application uses artificial intelligence with deep neural network module to identify the objects. The process is completed on the quad-core system, and the identified objects are listed in the terminal and displayed on screen in the host PC. The design and development of the 64-bit quad-core processor has been completed, ported on FPGA. Linux with different applications executed and benchmarks run. We are delighted and proud to announce the successful development of India's first indigenous 64-bit quad-core out-of-order microprocessor, as part of Phase 1 of the Microprocessor Development Program.